याद हो गया मुझको, हो गया है और जो हम बोला हाँ
ये सब हो गया।
Ma'am, you are muted.
Hello everyone, and welcome to our third session today on citizen science projects for women as well as everyone else. There's no restriction. Men are also welcome to join. Today we have our interesting session which is on the International Asteroid Search Campaign, and we have three speakers today. We have Mila Mitra, who will be starting off talking to you about the asteroid campaign. After which we'll have Amoli Kakkar, who will talk to us about more details. And today we have our interesting guest speaker, Patrick Miller, who is the director of IASC, who will also be joining us a little later. So let's start off with our speakers for today. So the first two speakers we first have Mila Mitra. So Dr. Mila Mitra is the co-founder and academic head of STEM in Space, an educational organization that encourages education through space domain. She's worked at NASA on missions like Cosmic Background Explorer. She's an active science communicator and has coordinated projects such as Asteroid Search Campaign for more than 10 years, as well as Globe at Night, Asteroid Day, etc. She gives regular public talks and writes a monthly science column in media. So welcome, Mila ma'am. Great to have you with us today. And I'll also introduce Amoli. Amoli Kakkar is our second speaker. She's a passionate amateur astronomer. She's an avid astrophotographer, has been featured on AVSO as an observer. She's taken part in several citizen science projects, discoveries she has to her credit. She's also trained students for the International Asteroid Search Campaign, which includes me. She's trained me too. And welcome, Amoli. Great to have you guys. And
thank you, ma'am.
Yeah. So I'll now hand it over to Mila ma'am, who's going to talk to us about the Asteroid Search Campaign.
Hello, everyone. Thanks for joining us here today. So many of us have participated in the International Asteroid Search Campaign. And, it's very popular. So many of our students and citizen scientists take part in it regularly. So, yeah, so we would, so I'm going to talk to you a little bit about what is this campaign and what do we do in it. And then I will hand it over to Amoli, who will talk further about how she participates or how citizen scientists can participate in it. So let me go ahead. Amritanshu, you can see my presentation?
Yes, ma'am.
Okay.
Perfectly.
So as you might know, some of you have been attending our series. We're doing a series of five webinars about citizen science projects, and all of you are welcome to join. And we are trying to give you an introduction so that you can find out about different projects. So today I'm talking about this one, which is International Asteroid Search Campaign, and the objective is to search for asteroids. So let's find out a bit about what are asteroids. Asteroids are small solar system bodies which orbit around the sun. They were actually formed at the time when the solar system was formed. They are leftover debris, and they're found in the inner solar system. What does that mean? They're found just after the three inner planets end. So they're found between the orbit of Mars and Jupiter. So they're also known as minor planets or planetoids because they're very small. They're smaller than planets, so they're known as minor planets. And mostly they are solid, rocky, and irregular, although the largest asteroid, Ceres, itself is spherical. So, and they don't have an atmosphere. So where are they located? Like I said, they're mostly in a belt of rocks. They're a belt of rocks between Mars and Jupiter. That's the asteroid belt, or called the main belt asteroid. And yes, that spells out to be MBA. And you all know MBA is a profession, but we all know it as the main belt asteroids. So the asteroids, they're not so well behaved. They cross over into the orbits of they get perturbed by the gravitational pull of Jupiter or other asteroids, and they sometimes fall out of the asteroid belt. And that's when they could create a problem. Okay, so there are some other locations. So they are classified based on their location. Let's talk about the main locations. Like I said, the main belt asteroids. Then there are the Trojan asteroids. You don't hear about them so often. The Trojan asteroids are a cluster of asteroids in front of Jupiter and behind Jupiter, and they share the same orbit as Jupiter. And the reason they can stay stable in those positions are because they're in what are called Lagrangian positions, which are stable. So they orbit along with Jupiter. And they are also found like this in trans-Neptune. So there are some trans-Neptunian orbits, asteroids also. Now, some of them that have fallen out of their orbits are called the near-Earth objects. And they are, there are many of them. All these red dots are near-Earth objects called NEO or NEA, near-Earth asteroids. And they are the ones that pose a threat to Earth. Okay, so here's the horizontal view, and you can see there are a lot of them. And that is why it's very important to look out for asteroids. So we are not just doing it, we are doing it for fun, but it is also very important to the fate of our Earth that we constantly follow and track asteroids. Okay, so here there are so many different orbits. So just going back to it, I would like to share, I think many of you might know about the projects, the missions that recently went, which is Lucy, the NASA Lucy mission and the NASA DART mission. Now the Lucy mission has actually sent a mission to Trojan asteroids for the first time. So because the Trojan asteroids are further away than the main belt asteroids, the mission is more complicated. It will take more time, but it will be visiting some Trojan asteroids. And the DART mission, which is called double asteroid deflection, that mission will actually try to hit an asteroid. It's a binary asteroid. It will try to hit it. And so at the end of this, some of you might ask, what's the point? Even if we know an asteroid is coming close, what's the point? How do we save ourselves? So DART is actually going to be doing that experiment by trying to deflect an asteroid by hitting it. So yes, scientists are also trying to solve the problem of what to do if an asteroid comes closer. So yes, we think that they're responsible for the extinction of dinosaurs. So we don't want another extinction event. So that's why we need to keep a close eye on the thousands of asteroids that are often in the news that they are going to passing by very close to Earth. Okay, so now you know that asteroids are important to study, but how do we find them? Just a second. Yeah, so there are multiple ways to look for asteroids. Astronomers look at them through ground-based telescopes. They scan the sky. There are space telescopes that look for asteroids. And there are many tracking programs and citizen science programs, such as IASC. So I'm going to share a short video of what happens how citizen scientists look for asteroids and what happens if they think they've found it.
How do we spot near-Earth asteroids? To start, survey telescopes scan the sky. When multiple pictures of the same spot show a speck that's moving, computers automatically check it against a database of known objects. If there's no match, it gets added to a list of objects to confirm. And if it looks like it'll pass very close to us, we give it top priority. Then it's time to call in reinforcements. More astronomers from NASA, other institutions, and even the amateur community submit additional observations. Each new data point helps refine the projected path, and this asteroid is going to fly right on by. All the info will be posted online, so it can continue to be. How do we
So yes, so there are telescopes that scan the sky and look for asteroids. So IASC is such a campaign. It is a citizen science project. It is for students and anybody who wants to be a citizen scientist. So it is an educational outreach program. It provides real astronomy data. So please keep in mind that whatever data you're getting is taken through a telescope and is coming to you. It's a unique part of the sky. So, you get access to real data and you can make original discoveries by working with this data. So IASC is very popular as a citizen science project. Every year, around 3,500 teams participate from more than 70 countries. Of course, there are many teams from India that participate regularly. And participants make discoveries, they make preliminary discoveries and also provisional discoveries, which are the final ones and that go down in the IAU Minor Planet Catalog of discoveries. Okay, so how does this work? The IASC is tied up with the Pan-STARRS Observatory, which is in Hawaii. So the telescopes at the Pan-STARRS Observatory take images, they survey the sky for moving objects, and they provide this data to IASC. And once you register yourself as a team, then your team will also receive these image sets through the IASC website. You can download it. You can use the software Astrometrica to look through these images. And if you find something that you think is an asteroid, you can save it as a report, and then you can submit the report. So the data comes to you. You can look for it using a software that I will demo briefly. And you can report all suspected asteroids, and then IASC will further look at it. They will try to confirm it. So that's how the process runs. And if you're taking part, it runs for a month. The campaign runs for a month. You will get many data sets that you can look through. So I just said moving objects, and so did the video. So let me tell you a little bit more about why we look for moving objects. So like I said, asteroids are moving in an orbit around in between Mars and Jupiter. So you can look for that movement. And there's a special technique to looking for the movement. So I'll show you an example. Here are two pictures. And if you look at it and I say spot the difference, then it's going to take you some time. There are differences, but it's going to take you time to spot it. But there is a process called blinking. So here's the same image, and I'm going to blink the two images back and forth. And now you can easily see the differences. So that is the process that is used. So IASC will give you 4 images like this. These are a time sequence. So because it's a time sequence, if you blink them like an animation, 1, 2, 3, 4, then you might see something moving, and that would be that could possibly be an asteroid. So here, there's a real example of a blinking, and you can see how one dot seems to move across. This is visually very hard to find if you compare 4 images, but with this blinking technique, it's very easy to spot. And this is a real asteroid. You can see the movement again. Okay, so I'm going to give you now a short demo on how the software works. I'm going to open up 4 images, and with that, I'm going to show you how you look for a blinking object. So it's just a short demo. So let me stop sharing for a minute. Yes, I'm just starting the software. So I'll start sharing again in a second. Okay, so I'm just describing this to you as a demo. It is a bit technical, and welcome, Patrick. Everybody, Patrick Miller is here now. So I'm just going to finish up. I'm giving a demo. And of course, Patrick is here, so he can talk it through. But we'll come to him in a minute. So right now, what I've done is I've opened up the software Astrometrica, and I've pulled in an image set that is a time series of 4 images. Images again being of a certain part of the sky. So the first step we do is we do an astrometric data reduction. So what that does is it does the first step of putting a coordinate system on this images that we pulled in. So before you can do anything else like blinking and looking for asteroids, you have to first do this data reduction step. Okay, so don't worry if it says not responding, because it always takes a bit of time. It's network intensive. So it takes a bit of time, but it's getting done. Okay, so once it's done, then you get a table like this, which tells you about how well the fit worked. So then you're ready now to do the moving object detection or blinking. So we do the blinking. And of course, you have all the controls. You can magnify it. You can do things, you can pan it or scroll it. And then if you look down here, where I'm annotating, you will see that there's an object that happens to be that small object near the bigger circle that appears to be moving. So yes, that is an asteroid that we suspect. So what we have to do next is we have to stop the blinking and forward it to image 1. And once we do that, you can click on it and it will show you what the image looks like, what the spec looks like that you have identified. It will give you information about it, and you can go ahead and save it with a name. So this is how, once you've saved it 4 times, then it will go, you can create a report, and that is the report you can submit. So yeah, so let me blink it again, and you'll see that that is the object that's blinking, and there may be more asteroids, more than one asteroid in the field. So there is another one. So down here, again, annotating it. So if you're a citizen scientist doing this project, this is what you would do. You would open the software, look at different data sets, and try to find these moving objects, record them, and then report them. So that is how this works. Okay, so with that, I think I'm done with the demo. So I'll stop this for now. So I hope you got an idea through what I said about what is IASC and what is the project about and why it's important. So we have a very special guest with us here today, Patrick Miller. So he's the director and founder of IASC. So Patrick, we are so pleased to have you here today. So let me introduce Patrick. Dr. Patrick Miller, professor of mathematics, also teaches introductory astronomy and astronomical research methods at Hardin-Simmons University in Texas. So he founded the IASC, which is International Astronomical Search Collaboration, in 2006, and serves as the vice president of the Permanent Council of the Global Hands-on Universe Association. So welcome, Patrick.
Thank you.
So
thank you, Mila. I'm certainly happy to be here today and have an opportunity to tell your viewers, attendance at this conference, follow up on what you discussed in the work that the fine work that you're doing, certainly in IASC and other areas of STEM. So let me, I have a brief PowerPoint to show you, but I need to be authorized to show it. So if the
Yeah,
host would let me-
I'll just give you
Okay.
that authorization.
Okay, all right, very good.
Yeah, you should have it now.
Indeed, very good. So let me just tell you a little bit about the history of the program, how it started, and how it's developed, and where we are today. This is IASC. We sometimes refer to it as IASC. That stands for the International Astronomical Search Collaboration, and there's our official logo, which we unabashedly took from the International Year of Astronomy. A lot of organizations did that, but anyway, that is our logo. Oh, hold on here. There we go. It was founded, as Mila said, in 2006. We started it in October 2006 at Hardin-Simmons University. That's a university here in Texas, the United States. What it is, it's an online educational outreach program in astronomy. It's targeted primarily for high schools and colleges, amateur astronomers, and other groups of citizen scientists. What we do is that we take images that are provided recently, or taken recently at a professional observatory, and then these participants, these citizen scientists, then are able to make original discoveries of asteroids using the method that Mila was talking about just a moment ago with astrometrica. And then once these observations are made and reported to IASC, we vet them. We make sure that they're accurate and then submit them to the Minor Planet Center at Harvard. That center is the world's official repository of all data regarding asteroids and minor objects, minor bodies in the solar system. That's recognized by the International Astronomical Union. Now, when we started, we had 5 schools, 5 participating groups. That's changed over the past 16 years. We now have grown to more than 6,000 citizen science groups, maybe 6,500 this year, located in 89 countries. So far, these citizen scientists have discovered more than 2,500 main belt asteroids. These are asteroids located in between the orbits of Mars and Jupiter. These are the ones that have provisional designations by the Minor Planet Center. They include 2 Earth-threatening near-Earth objects, more than 10 Trojan asteroids, which are in the orbits of Jupiter. And since February of 2019, these students and citizen scientists and amateur astronomers from all around the world have found over 8,400 faint objects, faint main belt asteroids, that have not been reported by any of the large NASA sky surveys. In the next couple of years, that'll reach 10,000. Of these, 76 have been cataloged and numbered by the International Astronomical Union in Paris. That's a long process from the time that the student observes the asteroid for the very first time to the time that it gets cataloged and then named. But 76 to date have been cataloged and named, and named by the citizen scientists and students who made the discovery. Here's just some basic statistics about the program, just to give you an idea what having to move the controls here so I can see it. Just to give you an idea about how it's grown. Starting in 2015, we had 300 groups of students, or 300 schools essentially. And you can see how it's grown each year thereafter. So year before it was at 3,000 and now it's over 6,000. And then to give you an idea of how many students are involved, citizen scientists are involved, that's the column over, it says number of participants, that's each year. So now it's over 40,000, approaching 50,000. Number of countries, well, I need to fix that slide. It's actually now 89. And then here's a breakdown of the by ethnicity. Although for India, that number is not that number is actually for the country of India. We have more schools and groups that participate from India than we do any other country in the world. Here's how the program works. Let me wait for this clock to finish. My wife collects clocks, and so when I give presentations like this, sometimes it's a problem on the hour. I'll be done in just a moment. This is a photograph of one of the telescopes we work with. This is the 1.8 meter telescope Pan-STARRS located in Hawaii on the island of Maui, on top of the second largest mountain in Hawaii, Haleakala. That telescope is managed by the University of Hawaii, the Institute for Astronomy. I'll tell you more about that in just a moment. And we received large amounts of data taken the night before or the previous nights before by that telescope. And we prepare that data and distribute them through a pipeline out to students using the pipeline and onto our website, managed at Hardin-Simmons University. Then the students, just like Mila did, download those images and put them into Astrometrica, and they blink them and they search for and they measure asteroid discoveries or detections. If they find one, then we have another group of telescopes around the world that can help us do a check, a follow-up. The Minor Planet Center requires that if you observe an asteroid, that within about 7 or 10 days, it has to be confirmed. There has to be a second observation. And so sometimes we do that through this other network. We repeat the process, do the measurements again, and then the students' reports and the follow-up reports then are submitted to the Minor Planet Center at Harvard and become a part of the official astronomical record. Now, I was telling you about that telescope. The primary telescope that we use here is Pan-STARRS. That stands for Panoramic Survey Telescope and Rapid Response System. It's a 1.8 meter telescope. It's not the world's largest telescope. It does have the world's largest camera attached. I'll tell you about that in just a moment. Well, here it is. The world's largest digital scientific camera. It produces images that stretch 3 square degrees across a field. That's about 6 times the size of a full moon. And that's large from an astronomer's point of view. And each one contains 1.4 billion pixels. What's remarkable is that those images are taken in 40 seconds or less. That's why they call this the Rapid Response System, Panoramic Survey Telescope and Rapid Response System, which is nicknamed Pan-STARRS. During a monthly campaign, we have campaigns 12 times a year. They're based upon the lunar cycle, and during a campaign, we'll have anywhere from 500 to 600 groups participating. We'll receive 65 of those large images from Pan-STARRS, and then we'll process and partition them into the smaller about 200 sub images. Those are the ones that are distributed out to the schools and teams. And those are what Mila was showing you on Astrometrica when she showed you the 2 asteroids. Those were one of the subfields from that massive image. And from one of these large images, these students and citizen scientists, they can discover as many as 150 main-belt asteroids, dot reported by Pan-STARRS in its nightly processing, or any other sky survey. These are original observations made by the participating students. Now, I did forget to mention one thing about this program, this IASC Asteroid program. It's free. There's no cost to participate to anybody, any citizen science group. Now, IASC was originally run by about 20 volunteers from all around the world, most of whom I had never met. That's how we were able to do this. Later, in the past 5 years, IASC has been funded by NASA to support its infrastructure and the processing of the images, the processing and delivery of the images to the to all of these thousands and thousands of students all over the world. But the people who join us and participate as our volunteers in support of the program, these are just a few of the countries, from Austria to Bulgaria, India, Italy, Mexico, of course, US. Some of the countries that have been involved as volunteers in the program. For example, Mila's group is one of our collaborators, and her group goes out and recruits students and trains them and has them participate on a regular basis in these monthly search campaigns. So here are some of the students over the years who've made discoveries. This is a young high school student, in high school at the time, she's now out of college, who discovered an asteroid. She was from, I think, a high school in the United States in Massachusetts. These are students here in Texas. These are college students here in Texas who discovered 3 asteroids. They went on to write a paper about their discoveries and submitted a paper and a poster presentation at a professional physics conference. Here are students in Brazil. This is Gustavo Rojas and his students near Puerto Alegre, Brazil, and they've also participated, made a number of observations, discoveries. This is Bulgaria. We work with an organization out of Varna in Bulgaria that is the National Observatory, and they have about 30 or 40 teams a year that participate in these monthly programs. This is China. This is Hongfeng Gao. At the time, she was with the National Observatory of China, and you can see that she's using astrometrica there. These are high school students in Beijing High School. This is Portugal. We have about 70 schools that participate from Portugal and former Portuguese colony. That's organized by one of our collaborators out of Lisbon called Nucleo. Japan. These are students at Shizuoka University. Some more students at Shizuoka University in Japan, all using astrometrica, just like Mila showed, looking for and making asteroid detections, discoveries. United States, these are high school students near Washington, D.C. Some more high school students near Washington. And these are some students in Mozambique who are on their laptop using astrometrica. India, I mentioned to you that we have more schools in India that participate in the IASC asteroid searches than we do any other country. I think the number now is close to 1,500 schools and teams out of India that participate each year. This is Poland. In fact, Poland was the very first country in 2007 outside the United States that participated in IASC, and has been participating ever since. I would say we probably have about 40 or 50 schools in Poland that participate. This was an award ceremony one time with a group of schools in one of the cities in Poland. This is Brazil. We also have a large number of schools. We have about 1,200 schools that participate each year for Brazil, not quite as many as India. These are students who are located near the city of Rio de Janeiro. They're showing their certificates because we do give certificates out to the students who actually participate and look through the data we provide searching for asteroids. Sao Tome, Principe, these are some middle school students, I think, looking at Isaac. Morocco, here are some students in Morocco who participate. This is a small rural school in Morocco, and they're having a day of celebration for their observations and the discoveries. Here are a couple students. These are Brazilian students. These are teenage students, 13 years old, I think, 14 maybe, who did some special work in IASC. And for that, we recognized them and have since submitted their names to the International Astronomical Union as names of asteroids. And so Christian Martins, showing his medal there in the top left, has been officially, as an official asteroid named after. His name is officially given to an asteroid, that 2007 KE7, and the Bruna Pontus in the bottom there is also was specially recognized. She has an asteroid named in her honor. And just around the world, I've forgotten exactly where these are, to be honest about it. I don't recognize that flag. Nepal? I'm not sure. But down on the bottom right are two girls from Space New Delhi in participating who detected a Mars crossing asteroid. And they received all sorts of recognition for that. And I think those two girls there at the bottom are from Bangladesh. So this brings this presentation to a close. This is we send out a Christmas greeting, holiday greeting each year near the end of the year, and this one shows you where Isaac is all around the world, starting from Hawaii and Texas, and the various countries all in between. So we invite you to join us. Mila is a good person to work with to do that. Her group does outstanding work and outreach with these students, and in no time at all, you could actually become part of this, and perhaps you too can make an asteroid discovery. Might even discover one of the Earth-threatening near-Earth objects, asteroids that pass near the Earth and pose a potential impact risk. So Mila, I'll turn it back over to you.
Yeah, thank you so much for giving us a overall view of IASC, how it started and where it's conducted. It was many of us here have groups that work on it from India, so we got the whole picture of where it's conducted. And I know you've been very active in bringing it forward to Brazil as well. So that was great. You shared that.
Well, as soon as I can travel again, I will be happy to travel to India.
Yeah.
And visit with your group and talk to all sorts of students.
I think that'll be great. Some of us here will try to, work towards that. So can you stay here till the end, or should we for another 20 minutes or?
Yes, I can stay.
Okay.
I'll be happy to.
So then everybody please list your questions. Meanwhile, I would also like to invite Amoli Kakkar ma'am, and she is going to give her experience as a citizen scientist, how she got into IASC and how she got interested in that, and what she has achieved so far. She will be talking for other citizen scientists, so that would give you all an encouragement to participate in this. And once Amoli has talked about that, then we will take questions for Patrick or any of us. So please do list your questions in the chat. And Amoli, please go ahead and tell us a little bit more about your experience with IASC.
Thank you, ma'am. Thank you so much. Working with IASC and doing the IASC campaigns has been a pleasure. And I think so I am fortunate enough to be introduced to IASC by Mila ma'am, you yourself. So I think so it's hard to commit any kind of a mistake because you are a perfectionist. I would rather try to let the other citizen scientists know how to register and how to go about and how to actually take a part in IASC campaigns. I'll just share my screen. Yeah. So this is the home page of IASC. And here we see some tabs like Home, Campaign, Astrometrica, Hall of Fame, and others. Here we see the three main tabs known as Register, Get Started, and the FAQ, that is the frequently asked questions. Now, when I click on Register, I get a few instructions here. First and the foremost thing is that each and every team should have at least 2 members so that it is easy for you to identify a moving object. Secondly, we need a Windows computer. We cannot work on the iOS. And the most important thing is a good internet connection. Then I click on Register. When I click on Register, I get a form like this where I fill in my team name, my country, and the team member's name. There can be about 6 to 7 team members in a single team. And I need to fill out the email IDs of each and every participant. And I mail it to the below address. Now, after I have done this and I have got a permission, I have already registered for the IASC campaign. I get a mail from them. And then what I need to do in the meanwhile, what I do is I go to Astrometrica setup. Here I click on it so that I can download my Astrometrica software. After downloading the software, once the campaign starts, we get a login ID and a password from the IASC. And you will see your team, the campaign name over here, wherever your campaign name is listed. When I click on this, I will see my team name, my individual team name, and I click on that and I am ready to go. I will see the image sets, I'll download them, and then I'll start working on them. Now, how do I know whether I can register for a campaign or not, if it is full or not? See, these are the year-long campaigns which happen. And every month there is a campaign. See, for the month of February till March, there is a campaign called All Bangladesh Asteroid Search Campaign. So there are many of them are full, except these 2. So you can register in All Turkey Asteroid Campaign or All Nepal Search Campaign. But preferably what we do is we go for our own country's campaign name. Once the campaign is over, we get some results which will show us how have we performed. Like the objects which we identified, are they probable asteroids or not? If they are the probable asteroids, the first detection is called the preliminary detection of an object. And the name which we give here, the name which we had given to that particular object will be highlighted here. The observers who had observed that particular object, their name will be listed here, and the team name and the country and the date on which we had discovered that particular object. Now, this is just a beginning. After we get the list of the preliminary list of objects which has been identified by us and recognized by IASC, then we get a list like this, which will show this list has the preliminary discoveries of each and every participant of all around the world. But we just shortlist our own. Then after the preliminary discovery, there is a second step, which shows that your discovery has been a provisional or not. What does provisional mean? Provisional is the second step where IASC confirms that yes, this could be a probable asteroid. It is confirming that it could be a probable asteroid. So that is a provisional discovery. It is still not confirmed. Now, this is the different steps through which we go throughout the campaign. And the provisional discoveries are stated once a year, so that all the discoveries, all the preliminary discoveries are checked and rechecked again, and then only the provisional discoveries are announced. After the announcement of the provisional discoveries or after the end of a campaign, we get some certificates. Now, like I had participated in Team Arundhati, which was an all-women's team, and I got a certificate like this, which says that I had participated in the campaign in the month of October. Similarly, if I get a provisional discovery, we get certificates of this type where the object name is present. In this case, it is 2021 NP12. So these are the certificates which we get once the object is approved by IASC. So these are some of the students who have actually have their provisional discoveries in their name in the month of May 2021, and here some of them of April 2021 from STEM and Space. And we are really proud that we as Indians are doing our job. Now, this is a preliminary certificate, and this is a provisional certificate where the object name is highlighted. He is one of my mentor, Mr. Sovan Acharya, who has helped me out in doing the different IASC campaigns and has trained me in fact, he has polished me to do the IASC campaigns, and now he has made me team leader of some of the particular teams. These are some of the people who have participated throughout the country. I would like to come to rest at this point, ma'am.
Great, and thank you for sharing your experiences as a citizen scientist. So I hope you've all now found out about IASC and how to participate. So I'm going to go ahead and ask Patrick some of the questions that people have posed. Okay, and Patrick, I think there are several of us here, including STEM and Space. I'm representing, there's Mars Observatory, there's Ignited Minds. We all conduct we all have teams that participate regularly in IASC. So thank you so much for the opportunity. Everybody's mentioning that. Okay, so questions. Janki Patel asks, if you find an asteroid, then what do? Keep looking at it or something?
Well, not through IASC. There's a network of telescopes around the world that are looking for asteroids. In particular, they're looking for the Earth-threatening ones. But that network does do surveys of the sky, and they will continue the observations of the asteroid. And what happens is that when you first observe it, you first detect it. Is what she was saying was a preliminary. And then when it's observed a second time, not by IASC, but by some of the large sky surveys, it becomes provisional. And after that, when it's observed additional times, 2 to 3 additional times, and the orbit's determined, then it becomes a numbered asteroid. So it's a continuous process that is overseen by a large group of observatories worldwide, and we're just one of the parts of it that make those original observations.
So Amit Raka, who's again has a team who participates often, he asks, how can we get updates on the preliminary discovery of asteroids?
Well, the preliminary asteroids, of course, are updated during a campaign. They're updated, the list is updated each Friday during the campaign. So during the campaign, you'll know, and in the campaign, IASC sends out a report on all the preliminaries that were found during that month.
Right.
Now, I suspect what you're asking is what happens after that. We monitor, we've got a program where we go into the Minor Planet Center and periodically check every couple of months, every 3 months perhaps, what's happened or what the status is on the preliminaries. And we identify, and that will tell us which preliminaries have been observed a second time and which ones have become provisionals. And we send out those provisional reports about every 90 days. So we keep records of all this that date back to the beginning of the program. And we know exactly what the status is of every, from preliminary to provisional and eventually to numbered. And the follow-up that we do is about every 90 days we go out and we check and update the provisional list.
Right.
And we report that back to you, or you can write Isaac, and we'll be happy to send that information to you.
And he also asked, how can we make IASC useful for school students?
Well, you know, what's interesting about the program, it's not really an asteroid discovery program. You may find that odd for me to say that. What it is an educational outreach tool for teachers and who want to introduce astronomy into their classrooms. Isaac has never been prescriptive on how to do that. We always rely upon the teacher in the classroom to decide, how do you want to take this tool and effectively bring it to your students and introduce these ideas and this science to your students. What we assure you is that it's a tool that works. It always works. We're available anytime you need it. 24/7, it's available. So as far as making it useful for your students, there are different ways that you can do that. Some teachers, for example, will first thing they come in the morning and are doing a science lesson, they'll show the entire class the images, and they'll work as a group in the entire class to search for asteroids. First thing that they do, and they do it as a group. Other teachers will save it for lab activities. That's what I do. I use it in my astronomy labs, and it'll be a unit that maybe lasts 3 or 4 weeks as a part of that lab. In addition to searching for asteroids, of course, I talked about asteroid science, what they are, where they came from, the science of these boulders of rock. Other teachers, one thing we notice is that when an entire class starts looking at asteroids, in the beginning they're very excited, but by the end of the month, only 2 or 3 are still excited. And so you always have 2 or 3 students in your class who are really interested in science and interested in doing these kinds of things. And so very often what the teachers will do is identify those students and let them do the asteroid searches as a special activity. So there are all sorts of ways that you can make this of use in your classroom with your students. How you do that's pretty much up to you.
So there are a couple of people who are asking, if they don't have a team and they want to participate, then how to start the process? I think Amoli mentioned register. Yeah.
Yeah, you still apply, and then Isaac will help you find a teammate. We'll either send you over to an organization like Mila's,
Right.
or find you someone in the area and recommend that you work together.
And
they don't have to live with you in the
Right.
same town.
Right.
They can be be able to reach them by internet.
And in fact, that is partly why we are doing this webinar here today. There are several of us who are in the SA Citizen Science group. So please do write there. So, we will try to team you up with somebody in one of the groups that do participate in IASC. Okay. So Shovan has a very interesting question that is there a process with deaf and mute people or blind people can participate? I know Shovan, as one of the leaders of this group, is trying to work into getting astronomy accessible to the disabled. So from that point of view, yeah. Probably
no.
not in this case. Yeah.
I don't really know. I don't really know the answer to that question. It is possible you would need somebody on site who's able to communicate the concepts. If someone is deaf.
Yeah, deaf and dumb is not a problem because this
bl-
is a visual. This is a
Right.
visual thing. If it can be explained to them through writing
Yeah.
or through
Be-
captions.
Not being able to see it, that would be kind of a hard problem. I don't know.
Right.
I don't know.
So
But I'd be very interested to find out if you do develop that, how that works.
and Amritanshu, you say that you had tried one team with partial visual impairment. Do you just want to address that? Come online and address that, Amritanshu.
Thanks, Mila ma'am, and greetings, Mila sir. So actually, in the month of September, October, there was one of the teams in which they were the students, they were suffering from partial visual impairment. So, and then they came out with say about 5 preliminary detections. I am not pretty much sure. So, but the condition is since they have to see, because to manually scan the images, some sort of sight has to be there. So we have tried with partial visual impairment and was successful also. So, but I really don't know with reference to a complete suffering from visual impairment.
Oh, that's fascinating.
Yeah, thanks for sharing that, Amritanshu.
Yes.
So any more questions for Patrick? Let's see if there are any more. So in fact, based on what Amritanshu just said, I have a question that few years back, we used to work with Astrometrica software when it used to do it in an automated way and try to identify some asteroids of its own. And then it got changed, so it's manual. Is there a reason for that? Is this a better way of working with the software?
It still can. It still does automated. However, it's not the utility that's in that program is not very good at finding moving objects. It's very good at finding bright ones.
Okay.
But
yeah.
the ones that we're interested in finding are too faint for the detection
Right.
or the automated detection to reliably find.
Right.
It just had too many false positives.
And in fact,
so what we said was, it's much better if you'll just do it manually. Now, I'll tell you this. We are developing a machine. We have developed a machine learning model that goes in and finds faint asteroids. And that model is just as good as at finding faint asteroids as the citizen scientists are. So we're hoping, well, what we plan to do is to develop a tool that will add to the faint model a separate image, a JPEG or PNG file, that will show the detections made by the machine. And then the students will look at those detections, validate them, and then go back to the original images to find them. And then when they're done, then they'll look at the images overall to see if the model missed something. Now, that raises an interesting thought I hadn't given consideration. It's possible that you can take the tool that we're going to be giving from the machine learning model and make a 3D rendition of it, sort of a braille rendition of it, that someone who's totally sight impaired would be able to feel it and decide, is that an asteroid or is that not an asteroid?
all right.
So that's what you talk about regarding impairment is something that might in fact be possible once we implement this new device, this new utility. It's a supplement to what we're currently doing.
Yeah, that will be great. Yeah. So I think we will probably end it pretty soon. So I just request everybody to come to put on your videos once so we can do a group photograph. Okay, so again, we are very honored to have Professor Patrick Miller with us here today. And thank you everyone for joining. IASC is a very popular program, and it's going to, any one of you can participate. So do contact any of us if you would like to participate. And I hope you learned enough about it today that you're all excited about it, and you would be interested in participating in this particular citizen science project. And next week, we are going to talk about astrophotography. And that's, especially how we've been doing it in the lockdown. Many of us, that's been a lifesaver. So looking forward to seeing you all next time. Priya ma'am is here. She's hosting all these webinars. And thank you again, Patrick, for being with us here today and giving such an enlightening talk. Thank you, everyone, for joining.
Thank you.
Bye.
Thank you.
Thank you, ma'am.
So Priya ma'am, you'll probably have to close the session because you're the host. So this session is over. We are just trying to close it because the host left. Amritanshu, are you still here? Are you able to close it?